Neil City.
I'm Neil Shanks Marshall.
I'm Will Morrow.
I'm Jacqueline Logan.
I'm Janet Ferguson.
And I'm Cameron App, and we're going to show you how to use environmental measurement devices.
What's our group name?
We don't have one.
Damn it, I was going to be like this. Hi, my name is Jacqueline Logan, and I am introducing the pH kit. I'm here discussing with my team about how to calibrate different instruments. Today, I will be dealing with the pH meter. You are going to need a pH meter, some Kim wipes, a pep bottle of 500 milliliters.
Well, you got to be free.
You can't just.
Oh, a
Just
distilled
keep going.
water, and your 3 contaminants to be able to pH calibrate. To be able to start, you're going to have to open up and check your pH meter. Check if the sponge is damp. Damp. This one is 4, you're starting with 7, and then 10. Here we are with starting with 4. We're going to make sure to turn on the instrument and check the battery. Battery, alright. To make sure this is alright, we're going to put this in the solution, and to make sure that it's calibrated, we are going to put this 2 to 3 centimeters in. Start to make sure that it is around a good number to start calibrating, because it needs to settle. It has settled at 3.96. We are going to press calibration. We're going to have to take a minute here to wait. Oh, it is calibrated at 4.11. To take it out and wash it in between instruments, you're going to rinse it with distilled water and dry it off with a Kim wipe to make sure there's no cross-contamination. To do this is the process of calibrating the machine before we start actually using the pH meter in another solution. Next, we use number 7. Again, it is starting again with putting it in and waiting for it to settle before we start calibrating the number. It is started at 7.4. We are calibrating. It calibrated at 17.13. Again, we're going to rinse it with distilled water to make sure you don't have any of the second base go into the last one. Make sure to not use many Kim wipes because they're expensive. Finally, we're going on to the last calibration before we use our pep bottle. This is number 10. Your last reading is a 10.05. Now moving on to our solution. We're going to just use top water from Glen College. We're going to need to make sure there is 0 space in the set. No? Okay. Cool.
12 o'clock.
I thought I did. My apologies. Now, the top solution. And the last reading is going to be neutral of 7.2 with a temperature of 21 and 9 Celsius. Thank you for watching. Have a good day. Finally, you leave everything spotless as you once had it when you arrived. The pH meter is rinsed off and replaced back in its case to its safety and security of its home. Thank you. Caps are screwed. The solutions will not run away and incapacitate anyone. And your day is collaborated. Thank you.
My name is Cameron Epp, and today I will be showing everyone how to use the conductivity meter. So, today I'm going to be using the conductivity meter. First step in using a conductivity meter is ensuring that the cable and the electrode are both properly installed on the meter. I'm going to inspect, make sure there's no loose wires or any damage to either the cable or the electrode. And then I'm going to check the whole meter to make sure there's no visible damage anywhere that may cause problems while taking measurements. Next, I'm going to turn the meter on and then make sure it is set to specific conductance. Specific conductance, you'll know when it's set to that when the degrees C is flashing on the temperature reading. I'm going to press mode until I can see the degrees C flashing. The specific conductance will measure the conductivity of the water at what it would be at 25 degrees Celsius, whereas the conductivity measurement will measure the water at the actual temperature of the sample. So now I'm going to collect my water sample from the tap. Alright. Now that I have my water sample, I'm first going to measure conductivity. So I will press mode and get back to conductivity. I will now dip the probe into the meter and bob it upside down until I have a stable conductivity reading. My conductivity reading is 462.9 microsiemens per centimeter. Now I'm going to switch my conductivity meter back into specific conductance and measure specific conductivity. The specific conductance for this water sample is 490.6 microsiemens per centimeter, and that'll be a reading which is extrapolated based off what the water temperature would be at 25 degrees Celsius. Right now the current water temperature is 22.0 degrees Celsius. As my final steps, before putting away the conductivity meter, I will rinse it with distilled water. On the bottom where the prong is and up top where the entry to the probe is there. Make sure it's rinsed well. And then I will place it back inside the meter, turn the meter off, and put it away.
Hello, my name is William Morrow. This is the dissolved oxygen or DO titration calibration startup. This is part one. So the first thing we're going to do is we're going to grab our water samples. For this lab, we're going to be using the tap. It's really important for the sample to have zero headspace, especially when you're measuring in dissolved oxygen, just because a little air bubble could make a larger difference in your overall sample. It's also important that you grab your sample from your titrator sample from the exact same spot as your larger PEP 200 or 500 sample. Ooh. Oh, awesome. Zero headspace in this one. And then I'm going to grab my titrator bottle from the exact same source, just so it's representative of, I don't know, the same area. Didn't really make any sense. Awesome. That one has zero headspace as well. Now that we have zero headspace in our samples, we can go ahead and start with the titration. This PET 500 I'm just going to put to the side and I'm going to use later for part two of the dissolved oxygen calibration. Okay, so I have my titration bottle here. The first thing I'm going to do is unscrew it and add in 8 drops of the manganese sulfate solution. 1, 2, 3, 4, 5, 6, 7, 8. And go ahead and put that one away. The next thing we're adding is the alkaline potassium, and it's going to be 8 drops of that as well. 1, 2, 3, 4, 5, 6, 7, 8. And you'll notice a precipitate is going to start to form, and we're just going to first shake it and then let it settle just to mix it around. So there's a shake, and now we'll just wait and let that settle. Once it's settled, we're going to get the sulfuric acid and then add 8 drops of that. I guess while I'm waiting for that to settle, I can start to fill up my titrator tube with the sodium thiphosphate, just so it's ready to go when we're all set. So I'm inserting it upside down, right, and I'm pulling it all the way back until I hit that 0 mark. Awesome, so right about there. Excellent, and I can just set that away for later. Okay, yeah, that looks good. Looks like our precipitate has settled enough. So now I'm going to add the sulfuric acid, and again, it's going to be 8 drops. One, 2, 3, 4, 5, 6, 7, 8. Awesome. I'm just going to cap it and then give it a swirl. Just wait for that to settle again. Okay, that looks like it's settled enough. I can pour some in. So now we're going to take the titrator tube here and we're going to fill it to 20 milliliters of our solution. And that looks to be about 20. Set this aside for now. Okay, so now that we have our solution measured to 20 milliliters in our sample bottle, we can start to add some of the, what is this? This is the sodium thiphosphate. And we're just going to add enough until it turns to a pale yellow. As I'm adding it, I'm going to be swirling at the same time and just looking for that change in color. Okay, that looks good. It's a nice pale yellow. I can set this titrator down and we're going to be using that again later. So the next step, we're going to be adding the starch indicator. I'm just going to pop the lid off the titrator tube here and I'm going to add 8 drops of the starch. 1, 2, 3, 4, 5, 6, 7, 8. Okay, awesome. Now that that's been added, it's going to turn a very dark color. It's going to be hopefully about a nice little blue. And then now that we have our color change, we're going to add the rest of this, the sodium thiphosphate until it turns clear. As I'm adding it, I'm just going to be shaking and dropping. Okay, so it's starting to change. Okay, so we're almost there. We ran out on our titrator, so we're just going to go ahead and add some more and take that into account when we read our final reading at the very end. So again, I'm filling it all the way up to 0. Flipping it back up. upside down. Okay, and then we're just going to keep adding it. And there we go, that looks to be about clear. Okay, so for our readings, we are reading at 11 parts per million, and that's taking into account the first syringe I've done. So now I'm just going to make sure I clean out my station. We're going to need to remember that number for 11 parts per million because it's going to be used in the second part of the dissolved oxygen calibration. For the rest of the sodium triphosphate, we can put it back into the original container. Excellent. And then with the rest of these chemicals, especially these two containers, we're going to make sure that we dispose of them in the back there by the fume hood. Oh, okay, well here we are back at the fume hood, and I'm just going to make sure I dispose of my chemicals properly. So we're going to dump out the one titrator container here, and then the tube next. And then I'm just going to want to make sure I'm rinsing with distilled water. Just so if someone were to come along and use it next, they're not getting any of my sample.
Mixed in, right?
Yeah, mixed in with what they...
Hi, I'm Janet, and I'm going to be talking about part 2 of the DO calibration with the DO meter. Will has already gone through and found out the concentration of the sample, so we're going to be testing that. So first, we check the overall condition of the machine, just to make sure that there's no cuts or anything in the wires, make sure it's all going to work properly. And the probe, that there's no damage done to it, there's no air bubbles or anything in there. Appears clean, looks good, so the housing's all good, so it can just stay in there. So this, as we said, Will has already tested and has established that there is 11 milligrams per liter concentration of dissolved oxygen. So we're now going to turn our machine on and let it run its little setup here. So that's all good. Let's back up. And so when I put this in here, it needs to be stirred around at a rate of 16 centimeters per second. So we're just going to set that there, make a bit of a mess. And just let that run until the readings here can stabilize. Still all over the place, and it needs to just keep moving so it doesn't use up the oxygen in any one particular spot of the water sample. So the numbers are still moving quite a bit on the screen here, so I'm just going to keep going for a bit. Okay. So now to enter this machine into the calibration mode, you're going to need to press both the up and down button at the same time. So the screen displays cal. And now it's entering the mode over to milligrams per liter, because that's what the units that it was, part 1 was calibrated into. So then we press enter. That's all good. And then we wait for this to stabilize and before entering in our known concentration rate. All right, so now that it's stabilized, I'm just going to use the arrow keys to adjust this to the 11 milligrams per liter that Will found in part 1. Just the one button pressing. All right, so that's set to 11 now. Then we press enter. And now it comes up asking for the salinity, so this is fresh water, so we're just going to keep that at 0, and enter. And now this meter has been calibrated and we are good to go and test this with another sample. So I'm just going to rinse this off with distilled water here. And we can just set this here until we're ready to test. I'm just going to triple rinse this. And then, same as in part 1, we want to be careful that there's little headspace on this. No headspace on this, actually. Okay. So if you're taking this elsewhere, we want the 0 headspace on here, but I'm testing it right now. So. And once again, it's at the 16 centimeters per second rotation rate. Alright, and so this sample has stabilized out at 11.68 milligrams per liter of dissolved oxygen and a temperature of 18.7 degrees Celsius. So now we're done. Once again, just a quick rinse of the distilled. It's all clean. And then we can put this all away. Turn off our machine.
Hi, I'm Neil, and I'll be doing the spectrophotometer portion of this video. So I've got it starting up right now. I've got the battery-powered one, so it is just starting up. And we're going to be testing a sample for sulfate. So I've got the manual for the different parameter methods here. It's open to sulfate. The method number for this is 8051. So I'm just going to grab a sample of Lindsay tap water.
Nice.
And get that going. So we've got our cuvettes here. They are both labeled 440, which is good because that way we know that we're working with the same cuvettes and there won't be any discrepancies between the two of them. So we are going to fill up our cuvettes to the 10 milliliter line. And then we just need to follow the instructions in the manual. So we need to start program 680. So I can go to options and I can find it that way, but we already have it set up right here. So we're preparing the sample cell, which I've just filled with our 10 milliliters. And then we are going to take our reagent for this process and open it up and put it into the cuvette. I have PET 500 here for the powder pillows. So that goes into the cuvette. And then we need to swirl the sample slightly. And then we go into our options here and we start a 5-minute timer to let the reaction occur. Alright, so our timer's just gone off, so let's stop that because it's annoying. And then we'll grab some Kim wipes. And we'll wipe off our blank cuvette with that so that there is nothing on the outside of the glass that is going to interfere with the spectrophotometer. And then open up the lid and place that in with the fill line to the right. Like that. And then make sure the lid is closed, and we're going to zero the instrument off of that blank. So now it's reading 0 milligrams per liter of sulfate. Now we can remove our blank and take our sample cell and clean that off with the Kim wipe as well. And then once again with the fill line to the right, you can put it inside the spectrophotometer. Make sure the lid is closed and just hit read. There we go, so we have a reading of 14 milligrams per liter of sulfate. And now that we have that, we can remove the cuvettes, dispose of the sample cell properly in the waste chem, and rinse out the cuvettes and clean everything up.
Alright, how does this waste chem work, Neil?
So we have our waste chem from the spectrophotometer for the sulfate. And I'm just going to dump it in there and then give it a rinse with distilled water to get rid of any of the chemicals that are still in there. And the other one was just tap water, so that can go down the drain and then also be rinsed with distilled water before put away.
Everybody at once. 3, 2, 1.
Jacqueline.
Hey, this is. We don't have a group name.
Oh, I thought we were just saying her names at the same time.
Alright, we're mobile.
Other than wanting to drink the
Yeah,
They didn't want us to drink it, why to make it look
This
so
is what
damn
you're
good?
making me want to do with myself, okay? You see that?
Make it look so damn delicious. How can I not drink that?
The colors.
Go for it. Save $5.
It's like
It's
when I
like
used to want to
lemonade.
eat.
I'll video as I'm going. There we go. There's the crew. There's me. And here's Will.